Hey guys, today we'll learn about absolute values and explore some past HSC questions to consolidate our understanding. Absolute value refers to the magnitude of a real number function without regard to its sign, or simply the displacement from the origin. Formally, the absolute value of x is represented as a piecewise function, so the absolute value of x equals to x when x is larger than or equal to 0, and the absolute value of x equals to negative x when x is less than 0. Let's take a look at this example, the absolute value of negative 3. When we plot negative 3 on the number line, we'll see that is displaced 3 units away from the origin. From the definition before, we can conclude that the absolute value of negative 3 is 3 because that's the distance away from the origin. In the preliminary course, absolute values are used primarily in two ways when talking about functions. One, when the absolute value of a whole function is asked, and this is represented as the absolute value of f of x. For example, the absolute value of x plus 3. Again, we express this using cases where it equals to x plus 3 when x is larger than or equal to negative 3, since negative 3 will make the function equal to 0, and negative x minus 3 when x is less than negative 3. 2. When the absolute value of the input of a function is asked. For example, if f of x equals to x squared minus 3x plus 4, when the input of x is absoluted, the function becomes absolute value of x squared minus 3 absolute value of x plus 4. Notice how the 4 remains the same because it's not a function of x. Again, we can represent the f of absolute value of x using cases. When x is larger than or equal to 0, the function will become x squared minus 3x plus 4. However, when x is less than 0, the function will become x squared plus 3x plus 4. The coefficient of x squared remains positive because a negative number squared is positive. However, the sign in front of 3x changes to positive because a negative multiplied by another negative becomes positive. Using the information gathered from the cases, we can represent this function graphically. From previous work, we know that y equals to x squared minus 3x plus 4 looks like this when the domain is restricted from 0 to positive infinity. We can calculate the y-intercept by letting x equal to 0, which will give us 0, 4. Another turning point can be derived from the negative b over 2a formula and subbing it back into the function, which will give us 1.5 and 1.75. The same applies to the negative case as well. When the domain of the function is restricted from negative infinity to 0, we calculate the turning point and the y-intercept the same way, giving us 0, 4 and negative 1.5, 1.75. Now let's take a look at a different type of question involving absolute values found in the 2006 HSC Mathematics paper. In this question, we're asked to solve the absolute value of x minus 1 greater than or equal to 3 and graphing our solutions on a number line. Although this question can be solved graphically, solving by cases using algebra is the fastest and most accurate method in this scenario. Now we should be able to derive the cases straight away, so let's get straight into the action. Case 1. X minus 1 is larger than or equal to 3. We simply add 1 to both sides to cancel out the negative 1, which will give us x is larger than or equal to 4. This maintains our domain, so this is a valid solution. Case 2. Negative x plus 1 is larger than 3. We can multiply negative 1 onto both sides, which will give us x minus 1 is less than negative 3. We add 1 on both sides, which will give us x is less than negative 2. This also maintains our domain, as the solution is less than 1, therefore is a valid solution. Now we can plot our solution, seeing as we have both solutions. X is greater than and equal to 4, and x is less than or equal to negative 2. Since they're both inclusive, a filled-in dot is used. In summary, absolute value is the displacement of a function from the origin. It is usually represented using a piecewise function consisting of positive and negative cases. When graphing absolute value of f of x, draw the original function and reflect components below the x-axis to the above. When graphing f of absolute value of x, draw the original function and reflect components from the right of y-axis to the left. When solving equations and inequalities of absolute values, use cases to calculate all possible solutions and eliminate answers that are outside a given domain. Thank you for watching. Hope you have learned something new today.